Good morning, everyone. Our lesson is about mixtures and their characteristics. The different materials around us vary depending on their composition. Some of them appear in their pure form, while others are combination of simpler materials. Mixture is a combination of two or more substances present in varied proportion. The gloves, face mask, and disinfectant solution are some of the examples of mixture because they were made combination of different materials. Halo-halo is an example of a mixture. In this mixture, you can distinguish some pieces of corn, beans, and other materials that make up the mixture in halo-halo. The mixed materials can be classified depending on the appearance of the resulting mixture. Each of the combined or mixed materials can be identified or distinguished from one another. This kind of mixture is called heterogeneous mixture. Each property of the materials in heterogeneous mixture do not change. So I have here an example of what do you call that? Heterogeneous mixture. This is a menu of my son Xavier. Okay? Egg with hot dog. Meaning you can identify which is the hot dog and which is the egg. That's why it is under the heterogeneous mixture. So, the types of mixture, aside from heterogeneous, and number one is homogeneous mixture, one which contains substances that are evenly mixed and is uniform throughout in terms of physical appearance. Just what I said earlier, heterogeneous mixture is one which contains component substances that are usually easy to distinguish. So if we are going to compare the two types of mixture, homogeneous, homogeneous mixture, we cannot identify the materials that we combine. Unlike in heterogeneous, that we easily distinguish the different materials combined. Homogeneous mixtures have uniform compositions where the substances are evenly mixed. They are called solution. In its component, the substance that dissolves or seems to disappear is called a solute, while the one that dissolves is the solvent. Okay, for example, I have here a clear glass, then water. And I have here a sugar. Okay, I will stir it. Until the sugar is totally dissolved. Okay, so the sugar is the solute, while the water that I poured here inside this glass is the solvent. So the main technique for us uh, to easily determine which is the solute and which is the solvent in the materials that we are going to mix to form a solution Uh, the water. Water is the universal solvent. Okay? And the one that we are going to dissolve using this water is the solute. Most of the time, the formation of this kind of mixture is associated with the process of dissolving. We say soluble if the solid solute completely dissolved in or in the liquid solvent. Okay, for example, like the white sugar. The white sugar totally dissolved in this solvent water. So meaning to say, sugar is an example of a soluble material. How about insoluble? In insoluble, if it is not dissolved, okay, while the components are both liquid, the term miscible or immiscible is used. Okay, let's talk about that miscible. So in this example, the sugar dissolved in water, meaning it is miscible also. It is miscible. Because when we are talking about miscible, they mix in all portions, meaning the sugar mixed with the water. Unlike when we are going to mix this water, again, water, then I am going to add cooking oil. So this is the cooking oil. I will add cooking oil in the water. Okay. See what happened to the cooking oil mixed with water. As you can see or as you observe, there there is a material on the top of the water, and that is the cooking oil. Okay? Meaning to say, the molecule of cooking oil is lighter than the molecule of the water. That's why we can see it on the top. And the molecule of the cooking oil do not mix with water. So this is an example of immiscible, meaning the cooking oil is not soluble or it is insoluble because it is not totally mixed with the water. Salt dissolves in water just like sugar. Salt is the solute and water is the solvent. This property of solute is called solubility. It is measured in the amount of solute that can dissolve in a fixed amount of solvent. Air is an example of gaseous solution. Metal alloys are examples of solutions in the solid phase. Ammonia water is a liquid solution made of ammonia gas dissolved in water. Ammonia gas is the solute and the water is the solvent. So as you can see, that's why water is the universal solvent. There are many materials that uh, we can dissolve by using water. In homogeneous mixtures like in vinegar, okay, I have here an example of a vinegar. I am not endorsing Dato Puti. Just in the available materials here uh, is Dato Puti suka or vinegar. Okay, but I am showing only vinegar is an example of homogeneous mixture because the materials that you mix to make this um, vinegar cannot be distinguished. So the dissolving components mixed are uniformly distributed throughout the mixture or at the same throughout. the components cannot be identified in a solution of homogeneous mixture. Another example, aside from this vinegar, is our fabric conditioner. No, this is a fabric conditioner. As you can see, from the bottom up to the top portion of this bottle, okay, the same throughout. That's why it is also an example of homogeneous mixture. Butter is an example of homogeneous mixture commonly found at home. So I have here a peanut butter. Okay, this peanut butter is the same. It is also an example of a homogeneous mixture because this peanut butter, the component from the top to the bottom are the same. So mixture commonly found at home, when you take any part of the mixture, you will get the same kind of material in any part. It is a solid homogeneous mixture. That's peanut butter, a solid homogeneous mixture. But this one, liquid homogeneous mixture, the vinegar. Types of homogeneous mixtures. There are three. One, solid homogeneous mixture. Number two, liquid homogeneous mixtures. And number three, gaseous homogeneous mixtures. So, example of solid homogeneous, cement. Cement is a solid homogeneous mixture of calcium compounds. Another example, yung coins. Yung coins natin na ginagamit pag tayo bumibili. Three, plastics. For example, like this plastic bottle. And then, woods. Okay? Like the door. Example of liquid homogeneous, number one is blood plasma. The liquid in our blood components. Milk is a homogeneous colloid. Wine, liquors, and water are also example of liquid homogeneous. Except distilled water. All water contain dissolved minerals and gases which are dissolved throughout the water. The mixture present in the same phase make water homogeneous in nature. Again, why do we think that water is an example of a homogeneous mixture? Because water, the mixture present in that particular example, make water homogeneous because it contains all the dissolved minerals and gases which are dissolved throughout the water. And the last example that I have here is the liquid detergent that I showed you earlier. In heterogeneous or non-uniform mixtures can be natural or man-made. Meaning, it can be coming from nature or it can be made by people. Much of the food we eat are heterogeneous mixture, just like the example that I showed to you. The menu of my son Xavier. Another example, when you are fried rice, when you are cooking fried rice. The chop suey, pinakbet. Are you familiar with pinakbet? There are so many ingredients that are mixed in pinakbet. We have the ampalaya, squash, okra, string beans, and others. And fruit salad. Suspension and colloids are the form of heterogeneous mixture. In suspensions, The dispersed ingredients particles are not really dissolved in the liquid. It later settles at the bottom of the container. It needs to be stirred to keep the concentration of the suspension consistent. For example, like the medicine, the antibiotic. As you can see, when your mother is allowing you to drink the antibiotic, what is the first thing that she's going to do before she will allow you to drink that medicine? She will shake it first so that all the ingredients will mix. Okay? Another example is when you are preparing milk or for example milk in a hot water. So when you let your uh, mix powdered milk with water, you observe that there are some particles on the top of it, and you need to get a spoon and stir it. Okay? Its particles are larger than those of a solution and a colloid. It appears cloudy. For example, when you are mixing soil and water. Soil and water is also an example of a suspension. And its particles are retained on filter paper. For example, if you are going to filter air. Just to sum it up, solution appears to be transparent. The light passes through with no scattering from solute particles, which are molecule in size. It is homogeneous and does not settle out, nor cannot be filtered. Even you use a filter paper, there is no material to be filtered, but can be separated using the process of distillation. A suspension like mixture of sand and water is cloudy and heterogeneous. Its particles are larger than 10,000 angstroms, which allows them to be filtered, allowing the suspension to stand, makes the particles to separate out from its components. So kung mapapansin nyo, kung meron kayo halimbawa na buhangin at saka tubig, pinaglahok ninyo ito, pag inyo sinala sa filter paper o kung whatever available material that you use in filtering, you can see that the sand can be separated from the water. And so that is an example of suspension. A colloid is intermediate between a solution and a suspension, while a suspension will separate out, a colloid will not. Okay? A colloid cannot be separated. Just like when you are cooking gelatin during fiesta and birthdays. Okay? After cooking that gelatin, you cannot separate the water and the gulaman bar from the gulaman from the water. That's why it is a colloid. Colloid can be distinguished from solution using the Tyndall effect. Light passing through a colloidal dispersion such as smoky or foggy. Parang siyang nagiging foggy. Parang may ulap, malabo. Will be reflected by the larger particles and the light beam will be visible. Example, soy sauce. Okay, yung ating toyo. Homogeneous mixture siya. Okay? Because, as just what I said, soy sauce, the materials that you mix in making that soy sauce, you cannot distinguish. Soy sauce, sauce of sardines, it is colloid because uniformly distributed. Okay? It is not what do you call that? It is not a solution, but instead it is a colloid. It is sticky. No? It is sticky than our first example, which is soy sauce.